Hello everybody, I welcome you back to my channel, and this video is gonna be a reaction to a recent dialect video about his matrix theory. And if you are following this channel for a while, you probably know that I have made several reactions to this channel already. And people from dialect were quite okay about it, and even recommended my videos on their channel. So I'm really thankful for that attitude. So the video is about different interpretations of special theory of relativity, the Lorentzian one and the Einsteinian one. The video suggests that these two theories alone can't ever achieve true logical coherency, but together they create a greater, more fundamental theory in a sense. The Lorentzian part here is for physicality or ontology, and the Einsteinian one for mathematics? I'm not sure, to be honest. But to sum it up, the author suggests that in reality there is one frame in which you measure the real length and time. This frame is the rest frame relative to the undetectable and all-pervading ether. And whenever you are moving relative to this ether, then you enter the matrix, where due to one-way speed of light problem and the principle of contravariance, you start making false projection of reality. And it feels like you are a stationary observer and everything else is undergoing time dilation and length contraction. But since this ether is undetectable, we can't ever know our state of motion relative to this ether. And therefore we can't ever know whether the reality we observe is real or merely a projection, and therefore the author says that we live in a matrix. The author starts with this thought experiment where you have a pencil that for unknown reason just shrinks. And the question is, how do you approach this problem? The author claims that you don't have to do any physics. You can just create a mathematical framework in which the shrinking is compensated by resizing the background. I know being a YouTuber is not always easy to communicate the idea the way you want, as the video can be only so long. But the way it's presented here can spark a wrong light on how physics is being done nowadays. If I had a certain object and I do nothing to it, and it remains at the same position and the state of motion, but it suddenly shrinks, then no math is gonna save me, because I don't know what is the cause of this shrinking, and therefore I can't predict when it's gonna happen again, and therefore I didn't solve anything. In special relativity, the shrinking is caused due to relative motion, and you have exact formula for the length of the object traveling at a certain velocity. So the cause is motion, but in the rest frame of the pencil, its length is gonna be always the same. What I think the author wanted to demonstrate here is this. You have a pencil at certain position in space, then you move it to another location, and you observe that its length has changed. Then you start asking, what is the cause of this length contraction? Maybe there is a different temperature or something. And therefore you obviously measure the temperature at these different locations. And if it happens to be different, then you heat up the second place to see if the length of the pencil gets back into its original shape. If not, then you have to find a different explanation. You can also test other locations and see how the length of the pencil behaves, and create a map which tells you how the length depends on the position. And this is basically a matrix. So what you might find out that there is a certain geometry that nicely describes the length of the pencil, depending on its position. Now the question becomes, is the space really curved? Or there is some unknown physical phenomenon that just by some coincidence happens to behave exactly the same way as if it was curved. The author claims here that true physicists should always pick the option B, and therefore there is some unknown physical phenomenon that we are not aware of. In special relativity we have time dilation and length contraction, and the space-time that just describes or causes these phenomena is the Minkowski space-time. And this is what the author has to say about this.
Fast forward 120 years, and you have a shocking number of physicists who sincerely believe that it is hyperbolic Minkowskian geometry which causes, rather than merely describes, time dilation and length contraction. But the representation is not the reality.
So, according to the author, Minkowski spacetime just describes the length contraction and time dilation. But he doesn't give any explanation why he thinks it is this case. This realization came out of nowhere. If the speed of light was just a few kilometers an hour, and we would discover this Minkowski geometry much sooner and had a perfect intuition for it, would it be physically correct to say, no, we are living in Euclidean geometry, which would be completely abstract for us, and we just don't know why physics behaves the way it does? Is this the correct way to do physics? It feels to me that the author considers spaces as purely mathematical object. Or maybe for some reason only the Euclidean one is a physical one. Okay, that being said, let's take a look what this Lorentz Aether theory actually offers us in terms of ontology. The author creates a very simple comparison of the Lorentzian and Einsteinian interpretations of the special theory of relativity, namely comparing their postulates. This image kinda creates an impression that Einstein's postulate is no less arbitrary than Lorentzian one. The speed of light being the same for every observer, no matter your velocity. The problem is that this is not a postulate of special relativity, but merely a consequence of its postulates. Although it's quite often regarded as a postulate, even though this is not the way how Einstein originally stated it. To make a better comparison of these two theories, let's take a look at them in more detail. The postulates of special relativity are actually very natural, and there is nothing weird or mystical about them. The first postulate is simply saying that the physical laws are the same in every inertial frame of reference. This is the principle of relativity, and it is known since Galileo Galilei, and the whole Newtonian physics is based on this postulate. And we even have a good intuition for it. The second postulate states that the speed of light is independent of the motion of the source. You might want to say that this is the weird one, but actually it's not, because this is exactly the way how all waves behave. For example, this postulate also applies for sound in air. It doesn't matter whether the source is moving or stationary. In both cases, the sound travels with the same speed relative to this air. The only thing that changes is the frequency. So again, very natural postulate, and we have a good intuition for it. So the postulates alone are not arbitrary. But when you try to put them together, then you will encounter problems, because at the first glance, these two postulates seem irreconcilable. Now, let's take a look at the Lorentzian interpretation. So there is a substance called ether, which has several properties. It's all-pervading, non-interacting with matter, and therefore undetectable. Light propagates at a constant velocity relative to this ether. Objects in motion relative to this ether physically shrink. And now we can compare and do a little bit of thinking to see what the postulates are actually telling us. Okay, so ether is all-pervading, non-interacting, and therefore undetectable. So we can't measure velocities relative to this medium. So if you think about this, it just implies the principle of relativity. And it kinda reduces to Einstein's first postulate. For the second one, light propagates at constant velocity relative to this ether. But this directly implies that the velocity of the light does not depend on the motion of the source, because it only moves at a constant speed relative to this medium. Therefore, it is exactly the same as Einstein's second postulate. But what the hell is this? You remember I told you that these two postulates are apparently irreconcilable, and it was a long battle between Newtonian physics and Maxwell's electromagnetism. Lorentz introduced a physical length contraction to make this ether theory consistent with observations. But this postulate was completely arbitrary. It was Albert Einstein who later showed that you don't need this postulate. And you don't even need any mystical, undetectable medium. And you can still reconcile these two postulates. Yes, you have to give up this notion of absolute 3D Euclidean space in which we are moving the same speed through time. But there is no good reason to think that this is the true nature of space and time we actually live in. Apart from the fact that our intuition is built such way since we don't experience very high velocities in everyday life. So thinking that nature of space and time must be the same also for high velocities is just a bias and nothing else. But if you think about it correctly, this Lorentzian interpretation doesn't offer us anything more than just picking one particular frame as stationary in which we measure the true length and time by definition. The author in the video says that special relativity compared to the Lorentz Aether theory doesn't offer us any physical content. But how physical is this ether? It is all-pervading, non-interacting, and basically undetectable. Is it physical? Moreover, why should special theory of relativity offer us anything more than we already have? It just changes the spatiotemporal structure of the universe we live in, so that the classical mechanics and electrodynamics can be consistent with each other. But the Lorentz Aether theory doesn't give us anything more than special theory of relativity. At one point, the author says this.
But then you have a brilliant idea. Why do physics when you can just do math?
This is clearly a suggestion that special theory of relativity is just mathematical theory and not a physical one, because it explains this length contraction through Minkowski geometry, which author thinks that it only describes this phenomenon, but he doesn't give any physical explanation. But if I wanted to make a similar statement for the Lorentz Aether theory, it will be something like this. Why to do anything when we can do nothing at all? Just postulate it as a physical fact. So unless there is a physical explanation for this length contraction that we can verify and test, then there is nothing that compared to the simplicity of the special relativity. It's just Occam's razor in practice, right? I believe that at the time of recording this video, the guys from Dialect are already working on the explanation of this length contraction. And I believe that they will come up with something, but it's certainly not gonna be something testable, and therefore certainly not better than special relativity. But seriously, look at what you guys presented in the video.
To explain the workings of the universe, a physicist or natural philosopher was expected to propose some sort of physical content which, existing outside of the mind, would serve as the causal mechanism for observable phenomena.
So ask yourself, if you are forcing this Euclidean 3D spatiotemporal structure for every velocity, where does it come from? If you really want to ask what is the reality outside of our brain without any bias, then we have to accept the Minkowski geometry, because it produces the correct results for every velocity. I really don't see, guys, how you want to justify this mystical undetectable ether and physical length contraction just to make this 3D Euclidean space work for every velocity. I don't see any objective reason for it, really. Like, imagine we are very naive and we want to describe the world with 2D space with time. And we would have this pencil that would start shrinking. And yes, there is a beautiful mathematical theory that maybe we live in a three-dimensional space. And this pencil is moving in the direction of this third dimension. And therefore it appears as if it was shrinking when we only limit ourselves to the two spatial dimensions. But we say no. It is nice description, but certainly not reality. Let's postulate some object contraction axiom, because we are supposed to do physics and not math, right? Isn't this the
height of pseudoscience?
But I think it's very important to have this conversation. And I must say that I have learned a lot making these reaction videos, because I would never think so deeply about certain issues dialect points out. And it's true that physical ontology of what is real is becoming more and more complicated in the modern physics. And it's very difficult to keep track of it, especially when we start talking about quantum mechanics. I think that there is much more space for such content like people from dialect make. So thank you for watching, and thanks to all of my supporters on Patreon, Buy Me Coffee, or Super Thanks. It helps me tremendously. And by the way, newly you can become my generous subscriber here on YouTube for $2 and have some extra emojis like stationary observer, moving observer, earth, just to help communicate the ideas in a comment. I can currently have only 5, but I will be allowed to add more with the number of generous subscribers. And you also get this number next to your nick in the comments, which represents for how long you've been subscribed. So consider. And if you are interested in more reactions to dialect, then watch one of these. I see you there.